Hello scholars, welcome to Fun Scholar. So in the last class we have discussed about the quadrilaterals and stopped at parallelogram. So from today we will start from rectangle and the rest of class will be completed in this one lecture. Okay, so let's start from rectangle. So what it's saying that rectangle is a parallelogram with all angles equal to 90 degree. So these two words should be focused, that is equal and 90 degree. Like this one will be equal to this one and this one will be equal to this one, and all the angles between them will be 90 degrees. So all properties of parallelogram it follows, and diagonals will be equal. These two will also be equal, and each angle is a right angle. We know that right angle means 90 degree. Okay, so let's see it a bit. So this one is the example of a parallelogram. Okay, why we are saying this parallelogram? Because these two sides are parallel to each other. That means that they won't meet together in any way. Okay, this one to this one and this one to this one. Okay. And now what they are trying to do, they are doing only if I make these angles right angle or 90 degrees, so this will become a rectangle just like this. So this is the actual figure or actual example of a rectangle whose each sides or each pair of sides are equal to each other and every angles are 90 degree. Okay, so this is the a simple introduction of rectangle. Okay, let's go further. Next, here is a video, that video time, that is a quadrilaterals tree. Okay, so let's watch the video, and you guys already know that I don't play very much videos here, but this one is quite important one, so that's why I am playing it. Okay, right. So watch the video carefully and we will discuss it about later.
We will now review the types of quadrilaterals and how they are interrelated. The first kind we studied was a trapezium. It looked something like this. It had one pair of opposite sides which are parallel. This is the only condition for a trapezium. One pair of opposite sides is parallel. A special case of trapezium was an isosceles trapezium. This is how it looked. Just like the trapezium, one pair of opposite sides is parallel, and the non-parallel sides are equal. Now that completes two types of quadrilaterals we have seen previously. The next kind of quadrilateral we saw was a kite. Well, it looks like a kite. It has two pairs of equal adjacent sides. This side is equal to this side, and this side is equal to this side. And its opposite sides are unequal. Then we come to a parallelogram, which has many special cases. A parallelogram has its opposite sides parallel. This side will be parallel to this side, and this one will be parallel to this one. This side will be equal to this side, and this side will be equal to this side. And a special case of a parallelogram is a rhombus, which looks like this. Its opposite sides are parallel to each other. This side will be parallel to this side, and this side will be parallel to this side. It has all its sides equal to each other. If you observe carefully, it satisfies all the properties of a parallelogram. Another special case of a parallelogram is a rectangle. It looks like this. It is a parallelogram which has all its angles equal to 90 degrees. And since it's a parallelogram, its opposite sides are equal too. Let's zoom out a bit and see the last special case. A special case of a rhombus is a square. It will have all the properties of a rhombus.
So here is the video, and in this video they have discussed that how these quadrilaterals will make a tree like this, like trapezium, kite, parallelogram, rhombus, isosceles trapezium, and again parallelogram can also be divided into rectangle and square, just like this, just like a tree. So this will be called as the quadrilateral tree, and it is just a video to make sure you guys don't forget about how they are coming from which one. Okay, so now let's discuss it a better. Okay, next. So this is the quadrilateral tree, how this is looks like. Okay, so quadrilaterals, trapezium, kite and parallelogram, these all are different types of quadrilateral. Trapezium who has quadrilateral means that 4 sides. Okay, 4 sides, and like they all have 4 sides, but talking about trapezium, the trapezium has only one pair of parallel lines, and when we make these 2 sides equal, it becomes an isosceles trapezium. Okay, the kite is normal, kite has these 2 sides equal and these 2 sides equal, so this is a kite. And talking about parallelogram, that when a parallelograms each angles are 90 degree, it will be called as a rectangle, and when each sides will be equal, I mean all sides will be equal, that will be called as a rhombus. And talking about when we combine rhombus and rectangle, that means that you have to make sure that all angles are equal, just like rectangle, that means a right angle or 90 degree, and all sides are equal, just like rhombus, it will form a square. Okay, just simply this one will be a rhombus, okay, whose every sides are equal but angles are not. This one will be a parallelogram whose every sides are parallel to each other and also equal, and this will be a rectangle whose every pair is equal, also the angles are 90 degree or right angled, and this will be a trapezium or isosceles trapezium whose one pair is parallel. Okay, and equal as well. Now equal means these 2 will be equal, and the parallel pair won't be equal, right? So let's go to the next one. Okay, there is another video, what is the relation of an exterior angle of a triangle with its interior angles. Okay, I am not playing the video, let's discuss it in further, like a relation of an exterior angle of a triangle with its interior angles. Okay, so the relation is simply that we already know that from the angle sum property, a triangle's 3 angles sum will be 180 degree, right? And talking about, if we extend this a little bit, the angle it has become that sum of these 2 angles. Okay, if I am telling A, B and C, here A plus B plus C will made of 180 degree, and if I consider the exterior part of angle C, it will be exterior part of angle C, it will be angle A plus angle B. So this is basically the relationship between these two. The exterior angle of a triangle with its interior angle. This is basically the relationship between all of this. Okay, let's go further. Okay, there is another video, that exterior angles of a triangle. Okay, I am not playing it, you guys already know that. Maybe you guys already wondered that how it is becoming. If I extend, if I draw a triangle like this and extend every side of it, then the angle they will made up will be the exterior angles, or will be called as the exterior angles. Okay, and then we can also give name of all of them. Okay, like A, B, C. So if I give name like what they have given name like EF and C. So EAB will be the exterior angle of angle A. ACD will be the exterior angle of angle C, and FBC will be the exterior angle of angle B, right? So let's go further. Okay, there is another video. What are the different properties of quadrilaterals? We will look at. Okay, you guys can simply assume that what will be the properties look like. Okay, the opposite sides will be parallel or equal. Opposite angles, that if I draw a parallelogram, if I draw a quadrilateral like this, so what the properties we have to look it about it. Okay, just like if I give you this one, okay, so what the properties or what the conditions it is having now. Okay, is the opposite sides parallel or equal? It is yes, that opposite sides are parallel as well as they are equal. And diagonals, are the diagonals perpendicular? Yes, obviously if I draw diagonals it will be perpendicular to each other. Okay, if they are equal or they bisect, yes, they bisect, but they are not equal. Are opposite angles equal? That opposite angles may be not equal. So it is parallel, the sides are equal, it will be a rhombus. Okay, so this is the method that we can find out, or rather I can say that you can just tell that whether it's which type of quadrilateral it is just by seeing the photo. Just like this one is rectangle, maybe it is not a perfect rectangle because the angles won't be 90 degree all, but angles have to be 90 degree to make it a rectangle. Okay, it looks like a rectangle. If I draw like this, okay, if all the sides are same, this will be a square. If I draw like this, okay, so this will be a parallelogram. So these are the conditions that we have to choose, or we have to separate all the quadrilaterals with each other. Okay, how do we prove that diagonals of an isosceles trapezium are equal? Okay, so this is another proof, and it has a video. Okay, I am playing this one because this is a theorem, and let's see that if you understand by watching the video of it, or else I am going to explain it further.
In this video, we will be proving a property of a special quadrilateral. Look at this quadrilateral ABCD. Sides AB and CD are parallel to each other, and the non-parallel sides AD and BC are equal. This is the data that is given to you. You may or may not be given the name of this quadrilateral. Seeing that we have one pair of opposite sides parallel, you should be able to say that it's a trapezium. And since the non-parallel sides are equal, we can say that it is an isosceles trapezium. But what do we have to prove here? We have to prove that AC is equal to BD, which means we have to prove that the diagonals are equal. How do we prove these two lengths equal? Whenever we have to prove two sides equal, So we modify the figure slightly. We can drop perpendiculars from A and B onto DC. This is a perpendicular from A onto DC. Let's call it AE. And this is the perpendicular from point B onto DC. And let's call it BF. Now focus on these two triangles. Triangle AED and triangle BFC. If we prove these two triangles equal, then we can say that angle ADC is equal to angle BCD. Note that the two triangles are right angled triangles. We know that AD is equal to BC. This data is already given. Now this is the interesting part. We can also say that these two lengths are equal. The distance between two parallel lines is always equal. We can say AE is equal to BF. That's because altitudes between two parallel lines are always equal. So in the two right triangle, the hypotenuse and one of the other sides are equal. So triangle AED is congruent to triangle BFC by the right angle hypotenuse side condition. So we can say that angle ADE is equal to angle BCF. They are corresponding angles of congruent triangles. So we have now proved these two angles equal. Now let's focus on these two triangles. Triangle ADC and triangle BCD. Let's redraw these two triangles so that it becomes a little easier. Triangle ADC looks something like this and triangle BCD looks like this. Side AD is equal to side BC, so we write AD is equal to BC. This angle is equal to this angle. Angle ADC is equal to angle BCD. This and this is actually the common side to both triangles. DC is equal to CD. So triangle ADC is congruent to triangle BCD. We use the SAS or side angle side condition to prove it. We can say that AC is equal to BD as they are corresponding sides of congruent triangles. We have proved what we were asked to. What exactly did we prove? We proved that diagonals of an isosceles trapezium are equal.
Okay, so the video is being completed. So what they have proved in this video is basically prove that the diagonals of an isosceles trapeziums are equal. So to do this, we have to first draw an isosceles trapezium and then we have to draw the diagonals. Okay, so then we have to then we can see that if we can prove that AC equals to BD, that means the diagonals are equal, we have to prove that. And to prove that, draw perpendicular from the A and B on DC. So we have to draw these two perpendiculars, and this step you should remember. And so if I draw these two perpendicular from this line to this line, from this point to this line and this point to this line, we can see that and perpendiculars are always right angle. So here we will see a right angle being formed. Okay, so and after this is formed, and we know that AD equals to BC because we know that isosceles triangles, these two sides will be equal, and AE and BF will also be equal because they are the same altitudes or to same parallel lines. So from this, and already AED and BFC will be equal because of the 90 degree. So this will form a congruent triangle. Okay, so from this congruent triangle we can see that when one side, one angle and another side is equal. So by the SAS rule we can tell that these two sides are equal, and from this we can say that these lines will also be equal, just like this. AC equals to BD. You need to practice it a little bit so that this theorem you won't make mistake to solve this. Okay, right, let's go to the next one. Okay, how do we prove that the diagonals of a kite are perpendicular to each other? This is another theorem. Okay, I am not playing the video here. You guys can easily watch videos in your free time in your home and try to solve it or try to remember it. Okay, let's see that how they are trying to do that. Okay, so we have to prove that the AC perpendicular to BD. Okay, so diagonals of a kite are perpendicular to each other. That means we have to first draw a kite and then we have to draw the diagonals. Okay, then after drawing the diagonals we have to show that AC perpendicular to BD. If AC is perpendicular to BD, then we can easily show that the diagonals are perpendicular to each other. So after drawing the diagonals, we can see that we have formed two different triangles. Okay, and we already know that AB and AD are equal from the kite's properties. So if AB is equal to AD and BC is equal to DC, we can say that AC is equals to AC because this is the common side and it will be always equal. So after getting these two triangles, we can say that AC is the common side and one side of each triangle will be equal, like from this one and this one and this one and this one, and AC is always the common side. So we can say from this that these two triangles will be a congruent triangle by congruency rule SAS, SSS. Okay, so from these 2 points we are getting that BAO equals to DAO, right? And again we have to prove this is for these two smaller triangles. Okay, for these two smaller triangle we have to show that SAS rule of congruency. Okay, and from that congruency we will get that these are the corresponding angles. Okay, so because of they are corresponding angles, they will have to be 90 degree, and we know that to become a perpendicular, the main property or the main requirement is to be 90 degree angle, that is being represented by this sign. So diagonals of a kite are perpendicular to each other. Okay, understand it? Just try to watch the theorem again and try to practice it. Okay, in home, to become good in theorem or by practicing theorem, you have to just practice it a little bit. Don't try to memorize it. Try to understand it. Yes, just there are few tips which should be memorized. Okay, and then you guys won't have any problems in solving theorems. Okay, or proving theorems, not solving it. Okay, how do we prove that diagonals of a rectangle are equal? Okay, this one is pretty much easy. That prove that the diagonals are equal. So we have to draw first a rectangle and then we have to draw the diagonals. So after drawing the diagonals, we are getting there are two triangles, that is ADC and BCD. Okay, and AD equals to BC, which will be the breadth of this rectangle, and we already know that AD equals to BC and AB equals to DC. Okay, and ADC and BCD are the right angles and DC and CD. So from one triangle we are getting from the SAS rule that they are congruent, and from after congruence, proving the congruency, we are getting AC equals to BD because they will be the corresponding sides. So this one is pretty much easy. So from this we can tell that AC and BD are the diagonals. So diagonals of a rectangle will be equal. So this is the proof of that diagonals of a rectangle are equal. Okay, right. Let's go to the next one. Okay, another question. So we solve a question that which of the following is not property of a rectangle? Opposite sides are parallel and equal. Sum of all interior angles are 360 degrees. The length of the diagonals are equal. Diagonals bisect each other at 90 degree. So we have already proved that opposite sides of parallel are equal. Sum of interior angles, that will be 360 degree. The length of the diagonals are equal, which we have just proved it. The last point is diagonal bisects each other at 90 degrees. So these won't be equal because they don't bisect each other in 90 degree, not every cases. Okay, so number 4 option will be wrong, and because they don't follow this rule everywhere. Okay, that is D. Okay, another video, how do we prove that opposite sides of a parallel are equal? This one is also pretty much easy, that we have to draw first a parallelogram and that's it. Okay, but we have to draw a little bit more after getting after drawing this, that is we have to draw a diagonal. So after drawing the diagonal, we are getting two triangles from here. Okay, that is ADC and AC or CBA or ACB or ABC, whatever you can tell this, and from these two triangles we will get two angles that will be called as the alternate angles, like DAC and BCA, because this one will be alternate to this one, and we will also get that DCA equals to BCA, BAC, this will also be alternate angles, and they have to be same. That's why we have written equal to sign or given equal to sign, and then AC equals to CA because they are the common side. Okay, so from this one we are getting that from the ASA congruency rule, that these two triangles are congruent to each other, and from this we will get two corresponding sides, that is AD equals to CB and DC equals to AB, and from this one we can say that and AB and DC are actually the opposite sides. So from this we will get that opposite sides of a parallelogram are equal. So the main purpose of theorem, that which we already know or which we are learning as the properties, we have to prove this geometrically or using algebra or sometimes using some arithmetic, we have to prove them mathematically. Okay, how do we prove that opposite angles of a parallelogram are equal? Okay, this one is also very much easy, that opposite angles of a parallelogram are equal. So to prove that, we have to draw the parallelogram first, and then we have to mark the angles of each one. Okay, so angle A equals to angle DAC, and then draw the diagonal. Okay, so angle A will be angle DAC plus BAC, and angle C will be angle BCA plus DCA. Okay, so from this one, and this one is pretty much easy, that DAC and BAC, if we join them, then the whole angle will be formed. Okay, so we can say this for angle A and angle C for both, and from angle C what we are getting, that BCA is actually DCA. Okay, sorry, DCA is DCA and BCA can be written as BAC. So from this we are getting that A and C are actually equal. Okay, and similarly we can prove that angle B is equals to angle D. So from this, from the whole proof, we can say that opposite angles of a parallelogram are equal. Another video, that how do we prove that diagonals of a parallelogram bisect to each other. Okay, I am play this video here because this is a little bit tricky one, you have to understand it. This video is important and will be beneficial for proving the next ones also.
Let us now cover another property of a parallelogram. We have to prove that the diagonals bisect each other. Let's take the parallelogram ABCD. Let's assume that the diagonals meet at point O. As it's a parallelogram, this side will be parallel to this side and this side will be parallel to this one. We need to prove that the diagonals bisect each other. It means we have to prove AO is equal to OC and OB is equal to OD. If we prove these two triangles congruent, we will accomplish our task. Corresponding sides will be equal and this will be proved. So we look at these two triangles, triangle AOB and triangle COD. This side is equal to this side because they are opposite sides of a parallelogram. AB is equal to CD. Note that these two sides are parallel and this diagonal is a transversal. So these two angles are alternate angles which will be equal. Angle OAB is equal to angle OCD. This diagonal is a transversal to these two parallel lines. So these two angles will be equal. Angle OBA is equal to angle OTC. Both these pairs form alternate angles. We have just proved two angles at an included side of a triangle equal to the corresponding two angles at an included side of another triangle. So triangle AOB is congruent to triangle COD by the angle side angle or ASA congruence condition. Therefore, side AO is equal to side CO. This side equals this side. They are corresponding sides of congruent triangles. Similarly, side OB is equal to side OD. This side is equal to this side. Don't forget what we actually proved. The diagonals of a parallelogram bisect each other.
So from this video we have learned that how using the alternate angles and the opposite sides of a parallelogram we can prove that diagonals bisect to each other. And to prove this one we have to just make them sure that they are bisecting perpendicularly. If they bisect perpendicularly, then the diagonals will be equal to each other. Okay, and this rule will be followed for rhombus as well. Okay, so to prove that diagonals bisect each other, we have to just show that they are bisecting at 90 degree each. Okay, and to prove that we have to differentiate two triangles and make them congruent by using ASA rule, and from the ASA rule we will get that AO equals to OC and OB equals to OD. That means that this diagonal will be equal to this diagonal, and from this we can say that they are bisecting each other at 90 degree. Okay, the next one. Okay, how do, and again that I have already told that rhombus bisect each other in right angle, and this will be also followed the same process. Just draw the rhombus and then draw their diagonals. From that diagonals we will get two triangles, and these two triangles we have to prove the congruency, and after proving the congruency we will get two corresponding angles, and these two corresponding angles will be 90 degree each. So from this we will get to know that they are bisecting each other at right angle. Okay, a rhombus is a parallelogram with all sides equal but not necessarily all angles being 90 degree. So this is the definition of rhombus, that a rhombus is a parallelogram which is okay, and all sides are equal. This is also okay, but not necessarily all angles being 90 degree. Yes, a rhombus is like this. Okay, it will look like this, whose all angles are not 90 degree, and from this one you can get that no angles are 90 degree maybe. Okay, each angle will be a little bit more than 90 degree, which is like an obtuse angle and or acute angle. Okay, but they will make sure that the sum will be 360 degree. Okay, so let's go to further. Let us combine rectangle and rhombus. Okay, we have to combine this, that a rhombus is sides. When we make all sides equal from the rhombus and all angles as 90 degree from the rectangle, if we take these two property from each one, then the thing we get, that is a square. Okay, so they are the identifying properties of square. Just like diagonals have two congruent diagonals that intersect at right angle and bisect each other. Okay, they are intersecting. Okay, the intersecting points will also be 90 degree. They are 90 degree each. The intersecting point will also be 90 degree. So this, if this one is 90 degree, this one is also be, this one is also, this one is also. Okay, and sides, all four sides are equal. Interior angles, all four interior angles are 90 degree like a rectangle. Okay, so these are the identifying properties of a square. Okay, next question is, find the length of the diagonal of a square whose side is 7 centimeter. Okay, so we also have formula for it, and we also do this by using Pythagoras theorem. Okay, so they have used the formula of it. Okay, the formula is simply, you just can remember the diagonal in the diagonal of a rectangle is the side square plus side square. From that we can get that side √2. That is the formula of a diagonal, and they have used the formula, but they have just explained it, just like writing that this means that square, this means is also square. They just, and diagonal is also square. If we make sure that the square changes side, then it will be a root, just like this one. Okay, so they just made sure, they just explained it, the formula a little bit, but the formula is diagonal of a rectangle equals to side into √2, right? Okay, another video, a summary of the properties of few special quadrilaterals. Okay, we don't have to, you can just watch this table to get to know about it, that parallelograms, sides are equal, parallel, and summary of the okay, just like rectangles, diagonal are not parallel. Okay, but diagonals are equal and they bisect each other. For rhombus, sides are equal, sides are parallel, diagonals are equal, diagonals are perpendicular. Okay. Okay, diagonals are specifics of quadrilaterals. So diagonals bisect each other for parallelogram. For rectangle, diagonals are equal and bisect each other. For square, diagonals are equal, bisect each other at right angle. For rhombus and kite are just like this. Okay, properties of a rhombus example. Okay, so the properties of a rhombus, and by which we can use properties of rhombus to find its area or its diagonal. Like if AC is given, that means the diagonal is 6 centimeter, and BD is given 8 centimeters. So we have to find the length of the sides. Okay, So just by using the Pythagoras theorem, and we already know that rhombus diagonals bisect each other. So that means by Pythagoras theorem we can see that AO, that means from AC we can say that AO will be 3 centimeter, and from BD we can tell that BO will be 4 centimeter. So from these two we will get the side of this one, and if we get the length of this side, we can always tell that the all lengths are same for rhombus. So the rhombuses every sides can be calculated just like this. Okay, and diagonals bisect each other, all sides are equal, diagonals are perpendicular to each other. So these are the properties by using which we can calculate anything of rhombus, right? Okay, let's go to the next one. Okay, let's practice. Find the measure of R in the given trapezium. Okay, so in the given trapezium the value of R will be 70 degree. Okay, and why this will be? Because they are following this rule that if this one is 110, this one will also be 110, and these two have to be 70 to make it 360. Okay, if I write it like this, then this one will also be 110, and they have to be 70 and 70 each to make it 110 into 2 plus 70 into 2, it will be 220 plus 140, that means 360. Okay. Next, in the given figure, ABCD is a kite with AC and BD as diagonals. ABC is 30 degree. So find X. To find X, we already know that ABC is 30 degree and BAC and BCA will be the same. Okay, these two angles have to be same. That is X, which we have to find. So we already know that they are same. That is X plus 30. And the fourth one will be, and they are making a triangle, right? And we know that from the angle sum property that all the sum of all the angles of a triangle is 180 degree. So 30 plus 2x equals to 180, and from this we can say that this is 75. And if you have to understand that is it 75 or not, ABC, this one is 30, so they are making 180, and if this is 180, this will also be 180 to make this as 360 degree. Okay. Next question, two adjacent angles of a parallelogram have equal measure. Find the measure of each of the angles of the parallelogram. Okay. So if ABCD is a parallelogram, sum of the adjacent angles of a parallelogram is 180 degree, which is given. That means that A and B, A plus B will be 180 degree. So from this we can say that if A and B is 180 degrees, so A and B will be 90 degree each, because from the properties of parallelogram we get to know that angles are equal. So from this we can say also that B and D will also be 90 degree, because 90 into 4 gives us 360 degree. Okay, so from this we can tell that B angle A equals to angle C equals to 90, and angle B equals to angle D equals to 90. Okay. In the above figure, both risk and clue are parallelograms. Find the value of X. Okay, so risk means RISK and clue means CLUE. Okay, and from this we can say that if this is 70, this will also be 70, and if this is 120, this will also be 120. Okay, and the rest of them will have to be like 120 each, that means 60 each. So this one will be 60, this one is 60 and this one will be 70. Okay, so this one have to be 50 degree maybe. So I think 50 is the answer will be. Also 150. 60 and 60, find the value of x. Okay, so from R, 6, oh sorry, I have made a mistake. It will be 60 plus 70 minus 50. Oh yes, they have made a mistake. It will be, yes, it will be 50. It will be 50 degree. It won't be 150 because 180 minus 130 is 50. So they made a mistake. I didn't. Okay, right? Yes. And they have written so many things. If you are not, if you don't have to, if you just understand the basics, that if this is 70, this will also be 70. This will also be 70, and if this is 120, this will also be 120, and 360 minus 240 gives us 120, and if this is 120, this will have to be again 160. Okay, so if they two are 60 and 70, so then x plus 70 plus 60, we already know from the angle sum property, that is 180 minus 130. Okay, so the answer will be 50, right? So let's go to the next one. Yes, ABC is a right angle triangle and O is the midpoint of the side opposite to the right angle. Explain why O is equivalent from A, B and C. The dotted lines are drawn additionally to help you. Okay, so this is a theoretical question, and AD and BC are drawn so that AD becomes perpendicular to BC and AB becomes not perpendicular, that is parallel. AD is parallel to BC and AB is parallel to DC, and AD equals to BC and AB equals to DC. So that is making ABCD as a rectangle, okay, which is making ABCD as a rectangle, and as opposite sides are equal and parallel to each other and all the interior angles are of 90 degree, which is automatically making a 90 degree. So this is a rectangle, and in rectangle diagonals are equal length and bisect each other. So from this property we will say that AO equals to OC, BO equals to BD, and the dotted line, that O point is the midpoint of side opposite to the right angle. O is equidistance, so O will be equidistance from A to B to C. Okay, and D is not written here before, so that's why O will be like C, right? This is another theorem actually. Okay, so let's end the class. So if you have any doubt, you can write in the comment section, and here is the summary that what we have learned from these two lectures. Okay, the last day we have discussed about polygons, classification of polygons, diagonals of polygon, convex, concave polygons, regular and irregular polygons, also practice some questions. Then in the next class, okay, this all covered in the first class, and up to parallelogram we have covered in the first class, and from today we all discussed about from the rectangle to kite, and also practice some questions in this class. In this class we also studied some theorems about it. So theorems you have to just practice a little bit more to get better in it. Okay, so let's end this class. Thank you everyone for watching this video, and hope you guys enjoyed it, and see you in the next class. Okay.